Okay, good morning. I'm Matteo Meucci from OWASP, and thank you, FOSDEM, for inviting me to speak here. It's my first time here in FOSDEM, and I think it's congratulations for your university because it's very nice, and I would like to study here, but I study in Italy, in Bologna. So, this is the agenda. I would like to introduce you the OWASP project and the new OWASP testing guide, that is a methodology to test the security of a web application. So I introduce how to test a web application, a short introduction, and then I would like to introduce how to improve software security in your software development life cycle, and then question and answers. Okay, 2 words about me. I founded the OWASP Italy chapter in 2005, and I lead the testing guide project from 2 years. And in the spare time, I work for Mind & Security, that is an application security company. So, who knows about OWASP? Oh, great, okay. So OWASP stands for the Open Web Application Security Project, and is a project dedicated to find and fighting the causes of insecure software. So we have an OWASP Foundation, and everyone is a volunteer inside OWASP. Everyone can participate. So everything we do is free and open source. So maybe is that for a reason that we are here now. Maybe. Okay. So the main object of OWASP is developing tools, standards, and documentation related to web application security. We have thousands of active members all around the world. We have more than 100 chapters around the world, and millions of it on our site. So if we think at OWASP, we have 4 areas. We have an area called education, in which we developed the first tool for the education of people on web application security. For example, the OWASP Top 10 tell you about the 10 vulnerability of the web application. So, for example, from cross-site scripting, SQL injection, and so on, tell you what are these vulnerability and how you can protect about it. Then we do training, we do conferences. So next conference is in Poland with Confidence. And we developed WebGot, that is an application that is vulnerable to web application security, so you can test on your own the vulnerability. This software also, the other is free, available on www.owasp.org. Then we have a community. We have a lot of chapters, and we have a lot of project incubator. And we have a wiki portal, so everyone can edit the contents of the wiki portal. Then we have a building area, and we have the OWASP building guide, that is a guide that tells you how develop secure software. There is a code review guide that tells you how to review the code for the security. Then there are other projects like Horizon, that is a tool that do a static analysis of the code. And then for the verification area, we have the testing guide, that is the core of the presentation. And we have a Web Scarab, that is a tool, is an HTTP proxy that runs on your local machine and can intercept all the HTTP requests from the client to the server. So you can see all the requests and edit it and see how the server can respond. So Web Scarab and the testing guide are together the framework for the testing. The testing guide is a methodology, and the Web Scarab is a king tool for the tester. Then we do validation and certification, but there are new items. So the testing guide is free and open. So we use the Creative Commons So everything is open and free. You can download everything we do. It's just a puzzle of the piece. It's just a piece of a puzzle. So you can see there are a lot of tools. And there is the building guide, the code review guide, and the testing guide. Here, the OWASP community, we have a lot of chapters all around the world in which we can debate the web application security, and we organize conferences locally, etc. Now the total projects in OWASP are 88. 42 related to tools and 32 related to documentations, and 9 for technology and 5 for the activities inside the OWASP Foundation. So all these projects are sponsored by the OWASP Foundation because we collect money from the conferences and maybe from the conferences, and so OWASP now gives some money to the leader that developed the documentation or tool. Now the goal is to improve the quality of our projects. So now all the projects are labeled alpha, beta, or release. For example, the OWASP Testing Guide is a release project. And so now our goal is to increase the quality and create professional OWASP books. So you can download from the site the PDF, for example, of the testing guide, or you can buy from lulu.com the book that is at the price of the printing. So it's less than $10, something like that. Okay. So this is now we will talk about the testing guide. Just a little history. The testing guide starts from January 2004 from Daniel Kapper that write the first testing guide that was 20 pages in which he collects all the tests to do on the application. And then in July the 40th, we developed the version 1.1, and in December 2006, we decided to develop a new project that is the version 2, that is more big than the other version. And now, in last December, we developed the version 3. You can see from here that the complexity of the project. From the beginning, we release a document of 10, 20 pages, then 30, then more than 250, and now we are nearly 350. So the complexity of the articles and the methodology is growing. It's growing. What are the goals of the OWASP testing? We would like to create a complete new project focused on web application penetration testing, and the goal is to we don't like to see the security as a black art. So we would like to share with the tester and with the auditor and with the other that are involved in the audit of the application, a common methodology. So the question is here to try to develop a methodology that is completely open. Okay, here the action plan. The last version, so the version 2, takes about 3-4 months to develop, and we begin with a brainstorming to understand which is the methodology. So we collect all the web application penetration test and experts, and we decide together to develop a common methodology. So the first stage is very complex because we have to collect all the ideas of the other and create the methodology, because we don't like to, we didn't want to create my methodology on your methodology, but the community methodology. So it's not so easy. Then, when we decide the index and the templates, we write down the articles on the wiki model. We review the articles, review all the guides, and then we write it in doc format and PDF, and then we release the candidate and so on. The testing guide version 3 started on April 2008, and firstly we do a OWASP leaders brainstorming about how to improve the version 2, and we do a call for participation. We had 21 authors, and in the version 2 we had nearly 50 authors, so the authors are less. Then we discuss all the article, and here you can see that there is an action plan about this guide. So here is the book that you can download from the site and the PDF. You can see there is introduction, etc. And chapter 4 is the core of the book, in which we describe the web application penetration testing methodology. And then we focus on how to write the reports. When you find all the vulnerabilities on a web application, we decide also to write a methodology to describe how to write a report, how to collect the vulnerability, how to value the risk associated with each vulnerability, etc. Because it's fundamental to present the result in the right manner. Then we have 4 appendix. We describe all the testing tools that we use. WebScarab is the king tool, but there are a lot of other tools. For example, for SQL injection, we have SQL Ninja, we have SQL Map, and so on. Then the reading, the FOSDEM vector, and the encode and injection. Now we go to see it better. The difference from the version 2 and the version 3. In the version 2, we had 8 subcategories, and now we have 10 subcategories. We create configuration management testing, and the authorization testing, and the encoded appendix. So here, I would like to show the index. Okay. Here we describe the OWASP testing framework and so on. And here you can see that we start from the information gathering, that is the first category of the test, and is the passive test, is not an active test. In the information gathering, we collect all the information about the application, so we understand all the entry points, where is the application, because maybe the target is only an IP address, so we have to understand where is the application, in which port is running, and so on. Okay. Then we do configuration management testing. For example, we go to see the strength of the SSL protocol implemented. We go to implement the infrastructure configuration management testing, and so on. And then we go for the authentication testing. And here we have split it in 10 controls to perform. The first one is to perform the credential transport over an encrypted channel. For example, when you have a username and password, to verify if the username and password information goes over an encrypted channel. And then we go for testing for user enumeration. For example, if you know a valid user, and if you try a not valid user with the wrong password, maybe the application responds in a different manner. So you can understand that the user is available on the application, and you can enumerate a lot of user. Then we can do the default guessable attack. Okay. Just a flash here. In the second part, I will show some examples, so I go a little bit fast. Then we do the session management testing. You know that web application running on over HTTP, and the HTTP protocol is a stateless protocol. So you have to implement your own state, or you use the framework, for example, from J2E or .NET. There is a session management mechanism. So here we test the strengths of this mechanism of the session management. Then we do authorization testing. When a user is authenticated on my application, I have to test if the user can do something that is not authorized for. Maybe he can read a PDF that is private, or he can do some action that is valid only from the administration, and so on. Then we do data validation testing. Data validation testing is the big one. Maybe I didn't find an application that suffered from a data validation vulnerabilities. It's quite impossible, because here we test all the entry point of the application, and we understand if how the application validate this information before doing a particular action. For example, create a SQL query on the database, or create an output on the browser. So if the validation is not correct, we can perform a cross-site scripting or SQL injection, and so on. So here we describe also for the SQL injection how to test the Oracle, how to test MySQL, SQL Server, and so on. Here are all the other data validation testing. Then we describe the Daniel service testing. Usually we didn't perform the Daniel service testing, because we touch the application not in the environment. The application is running, so it's not very important to understand if software of Daniel service. Then when we are a web service, we test also the web services. So here we describe how to test web services, and if we have an Ajax application, we describe how to test the Ajax. And then chapter 5 describe how to write reports and evaluate the real risk. So here is the index of the methodology. So what is a web application penetration testing? It's a process. It's a process that involves an active analysis of the application to find the weakness and the vulnerabilities. It's a black box process. So we don't know the source code of the application. We know only the URL on the IP address where the application is running. So this approach is a black box approach, and for example, the code review testing is a white box approach. When that means that you know everything about the code, so you can read the code, understand when a call is a function is called, etc. You can understand everything about the code. Here we don't know nothing. So the methodology described here with the tool is together web application testing. Our approach in writing the guide is open and collaborative. So you know everything can give his contribution, and collaborative because we decide together what to write, and it's not it's a community methodology. Then we would like to create a testing methodology that was consistent and repeatable under the time. So if I test an application with this methodology, we would like to have the same results from another tester. And yeah, the quality is another target. Here, for example, a testing paragraph template. Initially, we describe, we have a brief summary of what we want to test. We describe the issue, and we describe from a black box testing example and gray box testing example, and then we we collect all the references and the tools that are useful for this kind of test. For example, here is one of the paragraphs about the cross-site scripting, and here we describe what is a cross-site scripting inside the brief summary. We describe the issue, so how you can test for the cross-site scripting. And here, black box testing, the methodology. So you have to detect the input vector and to inject some script to understand how the application reflects your information on your browser. And for example, here is an example where, for example, you have the URL where user equal Mr. Smith, and Mr. Smith is reflected on the browser. So, for example, you can write down script alert 123/script instead Mr. Smith, and if you collect this kind of screenshot, you understand that the application doesn't validate the output. So you can create a reflected cross-site scripting. Okay. Here are other examples, and here are references. So you can read the white paper and the tools. Here again, Web Scalab, and OWASP call 9000 is another free tool that is a collection of web application security testing for the cross-site scripting, so you can use it, etc. Okay. Okay, here the difference, because we describe also the gray box testing. For example, if we know the session ID generation algorithm, we know something about the application. So it's something of a gray box testing. Okay, but again, the white box testing is not the target of this guide, but the code review guide, that is another guide of OWASP, is focused on the white box testing. So now I introduce the methodology with some examples. We start, I say that we start from the information gathering. So the first phase in the security assessment is to play with the application with a tool like Web Scalab or other tool, and understand how the application answers to you, and to find all the tree of the application, so all the directory accessible from the public, etc. So you can write down all the entry points of the application. Entry points, I mean the entry points, for example, when there is a form on the web page, when you insert username and password are two entry points of the application, and these are something that you have to test, for example, for data validation. So you can understand how the application is functioning during the information gathering, and then you use a spider and robots and crawlers to understand everything about the application, and then once identify the application entry points, we do web application fingerprinting to understand which are the web server, the application server running on the application. And then we do application discovery and analysis of error codes that are interesting. For example, when you try to request something particular and the application respond with, for example, Microsoft DB all error, you understand that there is some kind of database at the back end, and maybe you can collect information about the name of the table, and you can write down for the test for the SQL injection. So here you collect many information about your application. Here, for example, if you perform an HTTP head request from your target, the answer is something like that. And here, for example, you can understand that there is a Apache version 1.3.3, and there is a Unix server, and there is a Red Hat, etc. But For example, what if I do the same request and the header of the server is obfuscated? For example, here you can see at the third line obfuscated and obfuscated, etc. Also, we can understand that which is the server, because the header is in a different manner. So, for example, Apache 1.3.23 answer with date as fair field in the header, and so on. So you can understand which are the platform. Then we do configuration management testing. So, for example, the SSL strength of your application. We do DB listener testing, infrastructure configuration management. For example, we do also the old backup and reference files that we find quite a lot on the application. For example, if the login is login.jsp, if you try to request login.back or login.hold, maybe you can find this information, and maybe there are some information confidential inside these referenced file. So you can and once again found useful information for the test. Then we test, for example, for HTTP methods. For example, if put or delete is admitted on your web application, and maybe you can do other kind of test. Here, for example, we can find an access to Tomcat admin interface from the internet, maybe. Or here, from Nexus output, we can extract all the ciphers that the server admit. Here, for example, you can see that there is a DES and MD5 cryptography algorithm and hashing algorithm that are quite old, and it's not. It's better don't use it. Then we test the session management. Session management is a critical part of security test, because the HTTP is stateless, and so you have to understand how the application implements the state of the user that is authenticated on the application. So we test for the session management schemes, for the cookie attributes. For example, if when I authenticate on an application, I understand if I go to see if when the directive set cookie, I go to see if the cookie is secure, is HTTP only, if there is a date of in which is valid or not, and these are all attributes that you have to put on your cookie. Then we test for session fixation, for exposed variable, and cross-site request forgery. Now we see some example. Here, for example, on the right we have a web application, and on the left there is a user that holds his username and password. Here I post my username and password via HTTPS on the application, and on the bottom you can see the parameter, username and password. Then the web application verifies the credential, and if it's okay, the web application will generate a cookie and says, welcome to Mario Rossi, and if you look at the header of the answer of the web application, you can see something like that, a set cookie, authentication equals something, a string of characters that will be set on the browser of the user. So, for example, if I request many cookies of the application, for example, using WebScarab, you can collect a lot of cookies, 100, 1,000 of the application, so you can understand how the application generates the cookie. Maybe the application generates the same cookie every time. We don't find it, but or there is a linearity in the generation. Here, for example, is a very simple example. You can understand that if I collect a lot of cookie, I can understand that there is a linearity in generation, so I can understand that the next cookie is that one, just +2. So, for example, if I am authenticated on the web application and I request my money, how much money I have inside the bank, if I understand the mechanism of the session, I can modify that with the web scarab. So here I send to the web application not my cookies, not my ticket, but the ticket that I understand that is from another person. I don't know which person is, but I know that maybe there is an open session, so I can do a session hijacking. So the web application now verify my identity not from my username and password, but from the ticket, and the ticket is related to Mario Verdi and not Mario Rossi. So Mario Rossi can see the account of Mario Verdi. This is an example of session hijacking. Okay, another example here, for example, a web application where you can create your own MMS and then send it to a user via a network mobile phone. Here I don't describe everything, but the attacker is the first one on the left, and has a laptop and a mobile phone, and there is a spoofed identity with another phone, and there is a receiver with another phone. Here we can see that there is a stupid error, a stupid logic error, in which when I call the servlet for the payment, here you can see that I send a cookie that there is inside my MSISDN, so my telephone number. So I send him a session ID and my telephone number. What if I modify that number with another number, and we saw that the application doesn't validate the session ID, but validate only the MSISDN. So the result is that the application charge another user and not me. So I can send a spoofed MMS to another person and pay a spoofed identity. Another test, very interesting, is cross-site request forgery. That is a quite new vulnerability that is not so... we found a lot of cross-site request forgery, and I don't find the... Okay. I describe the test. We find the cross-site request forgery when the application permits to send an authorized function without authorize every time the user. And we use the image tag attack to create and force the user to commit that action. Now we see better. The first step is to find a vulnerability function. For example, if an application has a function to create a new user, or there is and this is only for the admin, for example, or there is a fund transfer, for example, all the online banking site permit you to create a fund transfer. We understand that there are this function. Then we analyze how I send this information to the server. For example, when I click submit, I want to create a transfer fund from my fund to another fund with 1,000 euro of fund. I understand which is the request. So I can create a malicious email or malicious site in which I force the browser of another user to do that action. The result is a not authorized action executed, but the user don't understand that. Another example. So, for example, online banking Here is the transfer fund mechanism. You can see the HTTPs, examplebank.com, the transfer function, in which is the variable are EU and 2. This is very, very simple to understand the vulnerability. For example, if I am authenticated and create a transfer to the account 1, 2, 3, 4, and this is the amount, the request is something like that. The second step is that the user must be authenticated on the application. The user, which is subject to the attack, must be authenticated on the application, and then I force him to request this HTTP request using the image tag. Here is the example. If I create a page like that, in which inside the HTML I insert the exact request that I understand that the application use for a transfer money, I can force a user to request this one. So, for example, if I send an email to 1 million user, and maybe one user is reading this email, consequently, if he is authenticated on the web application, the browser will execute this command. So the user don't understand that he is doing that, and the application sees that the correct user is doing that. So it's a big problem for saying, hey, I didn't do that, but the application sees that you are authenticated and you are performing that action. So it's a big problem to understand that you are not request this kind of transfer fund. So the cross-site request forgery is not is a big vulnerability to test and to understand. Then authentication testing. If you have question, please, because I see. Okay. Authentication testing. We go to see how the authentication mechanism is robust and so on. So we test the credential, we test for user enumeration, for user account, for the brute force of the web application, for bypassing the authentication schema. Here we can see some example. For example, here there is an application with mutual digital certificate, and you can see the user with his own public key certificate, and the application install a public key certificate on the proxy behind the application. So here we found, for example, that the handshake SSL and mutual authentication is from the user browser and the proxy. So on the layer beside the application layer, and then we analyzed that there is a script client that collects the information of the user certificate. So there is something inside the browser that go to see the user certificate and send the user distinguished name to the web application. So here you can see that there is an error, a logic error, because here is the authentication post. When I send from my browser to the server my user distinguished name, you can see in the last row, user distinguished name equal 100. So I do handshake SSL with the proxy, but from an application layer point of view, the client send to the application his distinguished name, and this is a big error because the application verify with SSL who is the user, and the application must see inside the certificate of the user, once that the certificate is verified, who is the user, but not asking to the user, which user are you? So here there is a big problem, because everyone here thinks that the application is very secure, because I give to every user a digital certificate. So I think that I implement a very secure mechanism, authentication mechanism. But if you go inside and understand all the requests that the application is doing with the browser, you can understand that there is a big security flaw. Okay. Then we do authorization testing. We test for path traversal, for bypassing authorization schema, and testing for privilege escalation. Here, for example, here you can see a site where you can download something from, for example, from the file system of the server. And what if you do something like that? The ID parameter here is validated, or you can insert everything and maybe navigate inside the file system of the web application. Here, for example, you can see the HPassWD, so all the running process, etc. Here, you can see how to bypass the authorization schema. So, for example, there is an add user JSP is part of an administrative menu. You can see that an admin can create a new fake user with role 3 and group 001, and you have to test if another user that has not the privilege of an admin can do the same. For example, if you understand that there are some administrative function, this test wants to verify if I do the same with no privileges, what is the answer of the application? The application is correctly validate the authorization mechanism or not. If you test it, maybe you can find a lot of surprise. Another test is testing for privilege escalation. For example, here, the server response after the user authentication. Here, the application uses an hidden field with the profile value. You can see sysinf1. And this value is the authorization parameter. And once again, is given on the client that, you know, everything that is on the client is Avial. So you have to verify that before using this information. And what if the user modify the value from sysinf1 to sysinf3? And in this case, we understand that we become the administrator of the application. So once again, the authorization must be on the server side, not on the client side. Then we perform a business logic testing that is okay. I run it a little bit. That is a test where we understand, for example, if there is a workflow inside the application, and to execute a particular function, I have to go throughout step 1, step 2, and step 3. What if from the step 1 go directly to step 3? There is some mechanism inside the application that verify that I have to do the step 2. That's another test. Then we go for data validation testing. Here, as I say, there are the main vulnerability. You can find the main vulnerability inside the application because the applications are full of entry points, and it's very difficult to verify all the entry points and validate correctly the output, the SQL query on the LDAP query, and so on. So here, for example, is a reflected cross-site scripting, where in the site there is a search field at the bottom, and what if I write something like that instead of home, I research for home or something like that. Maybe I can insert a script And if the output is something like that, I understand that the application doesn't validate the output. The stored cross-site scripting here, for example, we have a chat where you can see when you can insert a title, a message. What if the application permits to write an HTML and then you post something like that? And then when a user click on test cross-site scripting, we'll execute on the browser the script. So for example, I can steal the cookie of the user, or I can manipulate all the browser of the user. Okay, command injection. Here an example from WebGot. What if there is something like that in which I request a file on the file system and simply add something like that? The result here is something like that. You access to the file, but you can access also to the volume of the hard disk. Then we do web services testing. There is a plugin inside WebScarab that is very useful for the view WSDL. So when you find the service, you can use this plugin and you can insert, maybe you can see here, something inside the web service, understand how the web service can answer to your request. Here are some XML structural texting. For example, if I invert the tag of the XML request. Here, if I insert a large payload of inside the XML, what is the answer of the service? Then I shortly introduce you the web application testing. Then it's important to have a testing report model. So we create a OWASP risk rating model. It's very easy. It's risk is equal likelihood for the impact, and we need to identify a risk, get information about the vulnerability, the threat agent, and then understand the impact of the successful exploit on the business. Okay, so we can understand what to fix, what are the risk modes, etc. So here you can see that the writing report that we can suggest is something like that. An executive summary, a technical management overview, an assessment findings, and a table where for each category of test you can see all the vulnerabilities, the name of the vulnerabilities, and where is the effect item, where are the finding and the solution, and the evaluated risk about the vulnerability. Okay, so how can you improve software in software development lifecycle? The OWASP guidelines can help you to develop web application in a more secure manner. The building guide tells you how to develop the web application to protect for SQL injection, for example. The code review guide tells you from a white box test point of view how to test the function that you are implementing. So viewing the code, understand that there are security risks. And the testing guide tells you how to perform a SQL injection once that you have developed the web application and you don't know nothing about your web application. So inside the software development lifecycle, we can divide in 5 phases, from the define, design, develop, deploy, and maintenance phase. The controls to implement are training on the user, to do policy review, guidelines, adopt guidelines, doing code review, and doing web application penetration testing. So here is the big picture about the SDLC and OWASP guidelines. On the left, you can see that before the SDLC is improved, the OWASP guidelines can give you an help on how you can create your development lifecycle. And then in the define and design phases, you can use the building guide to develop a secure software. And in the development phase, you can use the code review guide. And before the deploy, using the testing guide that just described. SDLC is not a buy-to-box to buy because you know it's a very complex process. And okay, just a flash about the PCI standard and the OWASP. You can see that at the control 6.5, the PCI standard tell you to use the OWASP standard inside your application that you are collecting information about credit card number and so on. So this guide is useful. We think that this guide is useful for the industry, for the pen testers, so the company that do audit of the web application, and for the clients. So we have a methodology that is open and shared between the client and the audit. Future steps. In OWASP, we would like to integrate better the develop, the code review, and the testing guide, and improve the client-side security. And okay. So I thank all the authors of the version 3 of the testing guide, and we have 1 minute for the answer, for the question and answer.
If you could repeat the question.
Yeah.
You have described a set of tests to do in a black box approach. You also have said that we can have a white box approach. Code review, look at the code, and see if there are vulnerabilities for the code. What would be the balance to do between a white box and a black box approach?
Inside an organization?
Yes.
Yeah. We saw that many companies require web application penetration tests, so the black box approach. But we know that it's the last step that we have to do. So our idea is to begin to implement the control in the first phase of the software development lifecycle, so from the guidelines and for code review. So we know that doing code review is more effective than doing web application penetration testing. So your answer is correct. The code review is better. It's better for, because you can see the code, you can see everything about the code and see, okay, in this line, in this component, you have a problem. And you can write down the remediation immediately. And instead, if you do a black box code, a black box assessment, you know that there is a vulnerability, but maybe you don't know where inside your software, and it's more complicated, and it's another phase of the development, so more cost, and it's okay. Other questions? Thank you.